All right, geometry. So this is the second part of section 1.7 covering the distance formula or distance in the coordinate plane. And again, to be honest with you, you have done distance in the past. You did it in 8th grade. So you used what's called the Pythagorean theorem, and you'll see on the next slide that we attribute the distance formula to the Pythagorean theorem. Okay. And again, this is coordinate plane stuff, as we talked about with midpoints. All right, so here is the distance formula. So if I have 2 points, A at x1, y1, and B at x2, y2. So again, here's that notation. Then here's the distance formula. And this is long, clunky kind of formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, notice the minuses, right? So when you're trying to find the distance between two things, you subtract them, versus in the midpoint formula, finding the average, you add them. So let's take a look at this picture here. So here is point A, and here is point B. So this segment, that is the segment we're trying to find the length of, or the distance. You could also call D, you could call it AB without the bar. If you remember from our section 1.3 on segments, if you have AB with no bar, that means the length of segment AB. So however you want to think about it. So look what they did. They created this right triangle by drawing this horizontal and this vertical meeting at this right angle. And notice right here, this horizontal length is the difference between your two x coordinates. We're just going to call that the x. And then this vertical distance is the difference between your y coordinates, or the y. And what we're going to do is we're actually going to graph each of these problems, and we're just going to count the x and the y direction. And that's going to be our two numbers that go here and here. So our distance formula is going to boil down to this. Distance equals x squared plus y squared under the square root. And one thing we need to understand is that when you're squaring something, so if your number in here is negative, so say for instance that the x value is 5. When you square 5, you get 25. When you square negative 5, you also get positive 25. So what I'm trying to tell you is that it doesn't matter if your differences are positive and negative or negative. When you square it, it's going to turn positive. So if you have negative numbers in your problem after you square, you're doing something wrong. You're inputting the calculator wrong. You're doing something wrong. So again, my suggestion is just ignore this negative and just make it positive. Always make these two numbers positive and square them. That's my suggestion. So again, as I said right here, the distance formula is based off of the Pythagorean theorem. And again, this is a theorem we'll learn later in chapter 8. But again, I think you know it. This is what it looks like right here. So if you have a right triangle, you take the leg, which they call A, you square it. You take the leg, which they call B, you square it. And that equals the hypotenuse C squared. Now again, to try to make it look like the picture above, we're going to call C, D for distance. We're going to call A, X, because it's in the X direction. And we're going to call B, Y, because it's in the Y direction. And again, if I just substitute X squared plus Y squared equals D squared. And you might say, well, Mr. Chappell, this thing has a square root. Where does that come from? Well, notice here the D is not squared. So down here what we would do is we would take the square root of the right side, and we would also take the square root of the entire left side. So what that would mean is that the D would not be squared anymore, because a square root and a squared cancel each other out. They're inverse operations. And for this does not simplify, because you cannot distribute a square root across a plus sign. So this is just x squared plus y squared. And that is exactly what I have written up there. Okay. If there is a geometry OST this year, you have to know how to use the distance formula without any problem. Same thing on the ACT, SAT. There's always one or two distance formula problems. So be aware of knowing how to do these. Okay, so this is the notes portion. I'll make a video to cover the problems.